through logarithmic graphs with you. So the equation for logarithmic graph there's two types of logarithmic graphs that we work with. The first one is a log x to the base b, and the second one is a natural log x. For the second one, that's like saying a log x to the base e, in which e represented a number on our calculator. It was 2.71. It was an irrational number. I can't remember what the rest of the digits were that go with it. Okay? So, basically speaking, what you need to know today, and what you need to know out of this section is that the graph is the inverse of the exponential function, which means then that it has four characteristics as well, very similar to the exponential function. The first one is it has an x-intercept that crosses at 1. So 1 and 0 is your x-intercept. It's an increasing function that goes from quadrant 2 to quadrant 1. Okay? The domain is x is greater than 0. And the fourth one was the asymptote was y equals 0. So the asymptote is, of course, this line right here. That graph will approach this line, but never actually get there. Okay?
Isn't your behavior correlated?
Oh, sorry. Good point, CJ.
Thank you. It's not. I tried to find
4 to 1. And if it flips, it goes 1 to 4. So if the graph goes this way, then it's from 1 to 4. Okay?
what?
Okay. So if A is greater than 0, you get this blue graph. If A is less than 0, you get it flipped, which is the green graph. All right? That basically sums up all that you need to know from this. Now, there's a lot more that goes with it in terms of, I'll get to your question in a second, a lot more that goes with it in terms of what log is and how it, but realistically, you don't need to know any of that today. When we look at it in grade 12 pre-calculus, we need to know all of the other aspects of logarithms. But basically, all it is it says that if I look at the two graphs, for example, if I took this graph of y equals 2 to the x, this is the line y equals x. My graph of y equals log x to the base 2 is what we refer to as the inverse of that graph. Meaning it flips, it's a direct reflection over top of the y equals x line. But more importantly for you is if I look at the coordinates for this guy, let's use -3, -2, -1, 0, 1, 2, and 3. Okay, so this would be an eighth, a quarter, a half, 1, 2, 4, and 8. Okay, so that's my green graph, y equals 2 to the x. All right, my red graph would then read, switch the x and the y, an eighth, 3, a quarter, -2, a half, -1, 1, 0, 2, 1, 4, 2, and 8, 3. So all I do is I switch my x and my y values to get my new graph for my logarithm.
So how do you get the base exponent, like, how do you get the base of 2 on your calculator? How do you go log?
You can't.
So it's just log,
So just use it as base 10.
okay, so it's just log.
Okay.
and
So, all right. If I was asking, okay. Let me answer the question here first, then I'm gonna come back to yours. What's your question?
No, I was just looking at the figure. I was like, isn't that going down? But you're just, I was just.
Okay. So, if there's no value here, there's no base written right there. We understand that to be base 10. Okay, that's the base 10. Now, if I had this written out, and I was actually looking for this graph of the log of x to the base 2, you wouldn't be able to tell it apart very well from the log of x. You wouldn't be able to tell those two apart. To actually graph this, I have to do what we call change of base, and that is change them both to base 10. So I take the log of x and I divide it by the log of 2 because of the base here. So if you put that into your calculator,
Mine shows a bracket, that's okay, I just close the
yeah,
bracket.
just close the bracket. Yeah.
I get 10.977.
Well, no, yeah, I don't want an actual value here. I want you to graph it. Okay, so anyways, we don't need to do this. We are only graphing in base 10 right now. Okay? This would be base 10, this would be base 10 as well. All right, but I don't need to do this. So just leave it. Okay? Any other, let me go back 2 screens. Any other questions pertaining to this at the moment?
So like you said, so you switch the y, the x and y axis if you want from the top one to the bottom one,
That's
right?
right.
Okay.
Yes.
I'm putting that down on my cheat sheet.
Okay.
So the top one would be y because it has a y-intercept.
That's the y equals 2x equation. That equation is for this.
Oh,
This
so
equation is for
for
this.
log, okay.
Why do you say like log to the x to the base of 2? Why don't you just say, why does it go like that? Like if you go too long before that.
Because this 2 is your base here in this exponential function, right? When I change it to this, that's my base right there. So I say log x to the base 2.
Can you not say
I
log?
just showed you that on the screen.
Can you not say log 2x or something?
No, that's different. Completely different. Log 2x would be log 2x and then it'd be base 10.
I mean log 2 to the power of x. Can you say that?
No. No. It's log x to the base 2. Y equals 2 to the power of x. Okay. You don't actually solve anything here. This is just how you would graph it. So you would actually graph it by putting this into your calculator, log x divided by log 2, and then that would be your graph. But I don't need you to do that for only base 10 graphing. Sure. Okay, yeah. So that takes care of 7.4, and 7.5 is, again, back to our regression graph. So using all your stat stuff that we did before, exact same thing, except now we're looking for, now we're looking for calculate, and it's natural log regression, which is 9. Thanks. So you're using natural log regression, and then it's line 1, line 2, y1. And so it'll give you an equation, y equals a natural log x.
So log is 9, not b, right?
Let me see this for a second.
Oh, okay, see now, yeah.
So for like 7.2 and 7.3, we use the exponential regression, and then for 7.4, 7.5, we use the log regression.
It doesn't work.
Okay. So this is the regression one you would get right there. Okay, say, ask your question again, right?
So for 7.2 to like exponential.
That's right.
And then for 7.5
Natural log, yep, that's right.
Which number is that one?
9.
9?
And you're gonna get an A value and a B value. Now, the confusing part about this is this is going to have a direct effect on what your x-intercept is, because the whole graph has to shift up or down because of this A value. B acts like the same thing as if you flip it. So if B is greater than 0, it stays as an increasing function. If B is negative, it flips upside down. Okay, so we will play with this a little bit today, and then we'll answer any questions that you have as you go through it. All right, let's do this first. Let's look at page 192 and we'll do one together. So the population of Canada is given in the table in 10-year intervals. Use logarithmic regression to interpolate to determine in which year the population surpassed 20 million people. Okay?
So then the population.
So your population should be your Y value,
Okay, so then the years.
and the year should be your X value. Okay, so let's put that into our calculators right now. There's quite a bit of data that needs to go in there. Sorry, hold on a second. Just looking at their solution. Their population is X, their years is Y.
So then
Population is
L1.
X, L1, that's right. And years is Y or L2.
Make this a really complicated first. Do we have to put in both rows?
Yes, please.
I got an equation.
Okay, what did you get as your equation? What's your A value?
My A is minus 479.38.
Yeah, and your B?
58.686.
Perfect. Okay. So I got minus 479.381, is that right?
Yeah.
And then it's add 58 point something?
58.686.
Excellent, thank you.
I just got quick.
I got,
Bless you.
Bless you.
I got negative 13450.
Okay, check your numbers again, because this is the right answer.
Stash. And I go to 9, right?
Yeah. Same thing.
Oh, I know what they broke.
I got not that. That's a move.
Check your stat. Anybody else not get it? We're okay? All right, so your graph then
I'm just getting DI and mismatch.
looks like this. When you hit zoom fit, or zoom stat, sorry. Hit zoom stat.
Just get mismatch.
Okay. So again, mismatch. What does that error mean?
Your data
Yeah.
is not clear.
Your x and your y are not the same amount of values. Write that down on your cheat sheet.
There we go.
Got it, Rory?
Yeah.
So you didn't have it in there, right?
I had it all in there, except when I went to touch zero right here.
Okay. Okay. That's all I have for you. So that basically takes us to the end to 7.
I'm still getting the wrong answer.
Okay, I'll come look at it in a second.
Yeah, so it was on the exam.
Yeah.
Yeah, it was yours. Just like
there.
take it on people can put it in garbage and just forget that that is.
Okay. We're looking at a test Friday morning.
We're not
On
here.
chapter
We're not
7.
here Friday. We're on.
Oh, you guys are on the English trip.
So,
Thursday morning's a test.
oh!
Thursday morning's a test. You got everything done. You should have, if you were here last Friday, you have everything done.
Leave at 8.
No, we
No, we leave at 11:30. So we have class. So we'll leave right after the test.
They can plot begins though.
When you going to Winnipeg?
Yeah.
Oh, you're coming with us?
Yes. But I'm not coming home with you.
Did Dad call you to say he was gonna-
Is he?
Does anybody have
You're
a chat?
not even friends.
Okay, go to work then, please. The pre-test is done and it's on the back shelf here.
Just good thing